Welcome to the channel. This video offers a 2026 adoption blueprint for library and information professionals navigating the integration of artificial intelligence into their institutions. We will examine three interconnected domains: the strategic adoption of AI tools, the mitigation of associated risks, and the development of staff competency frameworks suited to the demands of an AI-mediated knowledge environment. This is a practitioner-oriented, evidence-based discussion drawn from the most current global developments in library and information science. Let us begin by establishing the current landscape of AI adoption across libraries worldwide. This presents a critical data point that frames the entire discussion. 67% of libraries globally are actively exploring or implementing artificial intelligence in 2026. This is not a marginal phenomenon. It represents a decisive shift in the operational philosophy of library institutions. The diagram on the right illustrates the broader transformation underway. Libraries are moving from their traditional role as passive information providers toward becoming active, AI-supported knowledge ecosystems. Active 2026 deployments already include Microsoft Copilot, Libby's Inspire Me recommendation engine, TensorFlow and PyTorch frameworks for automated metadata extraction, and IMLS-funded multimillion-dollar AI literacy initiatives. With this adoption landscape established, we must now examine precisely how AI is altering the fundamental mechanisms of knowledge discovery. Here is a comparative analysis of two distinct models of knowledge discovery. Under traditional discovery, users employ keyword-reliant search mechanisms, navigation is human-directed and curated, the research path remains transparent and visible, and the outcome is characteristically serendipitous exploration. Under AI-mediated discovery, the mechanism shifts to semantic and intent-driven queries, navigation is delivered through machine synthesis, the research path becomes obscured as AI bypasses traditional systems, and the outcome is precision-focused delivery. The foundational implication, as stated at the base of this slide, is that knowledge is no longer merely discovered by human effort, it is increasingly delivered by machines. This raises profound institutional and professional questions that we will examine throughout this presentation. The next slide illustrates this shift through a concrete operational example. On the left, the traditional keyword match model, a search for the phrase, "Climate Change Agriculture India," retrieves only documents containing that exact terminology. Valuable adjacent resources, on food security, rainfall variability, or economic impacts, are entirely missed due to terminological gaps. On the right, Yale University Libraries AI pilot demonstrates the semantic node web approach. The same query now surfaces contextually related concepts automatically, expanding discovery across food security, economic impacts, and rainfall variability simultaneously. Semantic search understands the intent behind the query, not merely its surface form. This example illustrates why AI-powered discovery represents a qualitative, not merely incremental, improvement. We turn next to examine how AI is transforming library administration through automation. OpenClaw, an open-source AI agent that is redefining administrative efficiency in library operations. The workflow illustrated here involves three sequential stages. First, extraction. OpenClaw operates as a human-like browser agent, retrieving bibliographic data directly from publisher websites and online catalogs. Second, conversion. The extracted data is transformed into standard library formats, specifically MARC and Dublin Core, maintaining compliance with established metadata standards. Third, upload. The structured records are securely entered into the integrated library system via a local-first architecture that ensures patron data remains protected from external exposure. The measurable impact of this workflow is significant. administrative cataloging tasks that previously required 10 to 15 minutes of manual effort are completed in under 5 seconds. We will now examine additional practical tools that are delivering comparable results across library functions today. This slide catalogs 3 categories of AI tools currently producing demonstrable outcomes in library practice. First, custom GPTs such as Click and Catalog. These tools extract bibliographic data from book cover images, assign Dewey Decimal Classification numbers, and generate initial mark records within minutes, while preserving the essential role of human review and verification. Second, integrated library systems. AI is now natively embedded within platforms such as Ex Libris Alma, through its metadata assistant, and Primo, through its research assistant, enabling faster record creation and enriched discovery workflows without requiring separate tool adoption. Third, domain-specific AI enclaves. These are secure, private AI networks trained exclusively on a library's own internal collections and archives, ensuring both localized accuracy and zero risk of data leakage to public large language model systems. Having established what AI can accomplish, we must now turn to its risks and the ethical obligations these generate. This slide presents a case study of critical importance to all information professionals. The flowchart illustrates a documented failure mode. A legal practitioner queries generative AI for a specific precedent. The AI synthesizes plausible-sounding language and fabricates a non-existent case, Mercy versus Mankind. This fabricated citation is then submitted in a formal legal petition without verification against authoritative databases such as SCC Online or Manupatra. India's Supreme Court has now identified this as a systemic concern. Chief Justice Surya Kant described the trend as absolutely uncalled for and alarming. The institutional lesson is unambiguous. AI is a powerful assistant, but it is not a reliable authority. For library professionals, this case study underscores our unique institutional responsibility to serve as knowledge gatekeepers, promoting rigorous verification practices in all AI-assisted information environments. The next slide examines further hidden costs embedded within AI integration. There are 4 systemic risks that library institutions must address as part of any responsible AI adoption strategy. Algorithmic bias. AI models learn from historical data and can perpetuate and amplify existing inequities, directly threatening the library's foundational mission of equitable and fair information access. Sustainability. Generative AI systems consume substantial quantities of energy and water, raising concerns for institutions committed to eco-friendly and green operational practices. Privacy and security. Feeding patron data, user search behaviors, or proprietary institutional research into public large language model systems creates significant exposure to privacy violations and data breaches. Erosion of trust. Without strict transparency mechanisms, AI systems seamlessly blend peer-reviewed, credible sources with unreliable hallucinations, fundamentally undermining institutional authority. Understanding these costs is essential to appreciating the strategic equilibrium that the next slide introduces. The graph plots 2 trajectories against time and increasing AI integration. The first, technological velocity and automation, follows an exponential curve as AI handles more back-end processing and enables frictionless discovery. Its operational power accelerates rapidly. The second, the value of human validation and trust, follows a steady, linear upward trajectory. As the annotation explains, when AI assumes responsibility for retrieval speed and efficiency, the primary asset of the library institution shifts fundamentally. It is no longer the speed of information retrieval that defines institutional value. It is the guarantee of trust, ethical governance, and authoritative validation. In a world saturated with AI-generated content, the library's human expertise becomes more valuable, not less. This equilibrium directly informs how we must now redefine librarian competencies for the AI era. Here is a structured comparison between the pre-AI professional focus and the competency framework required of library professionals in 2026. Previously, the emphasis was on teaching users how to search the catalog. Today, the focus shifts to teaching users how to critically verify AI-generated outputs. Previously, the goal was mastering individual software tools. Today, it extends to designing effective prompts and auditing algorithmic behavior. Previously, librarians curated physical and digital collections. Today, they are called upon to shape and govern local AI data environments. Previously, the librarian acted as a guide to resources. Today, the role evolves to that of an ethical gatekeeper against misinformation. These are not superficial updates to job descriptions. They represent a fundamental reconfiguration of professional identity. The following slide proposes a practical training model for building these competencies within existing staff. Here is a structured, evidence-informed staff development model that can be implemented within a 2-hour session. The first segment, occupying 25% of the session or 30 minutes, focuses on AI basics, demystifying the technology, defining large language models, and explaining the mechanics of semantic search without recourse to technical jargon. The second segment, at 37.5% or 45 minutes, involves hands-on pilots. Participants engage directly with specific tools such as the ALMA metadata assistant or institutional cataloging GPTs in task-based scenarios. The third segment, also 45 minutes, applies the REAL evaluation framework assessing AI outputs against 4 criteria: relevance, ethics, accuracy, and limitations. This model prioritizes professional judgment over mere tool familiarity, producing confident and critically informed practitioners. With competency development addressed, we now turn to the strategic blueprint for institutional adoption. This slide synthesizes the preceding analysis into a 3-phase institutional adoption framework. Phase 1, Pilot and Measure. Institutions should initiate focused 4 to 6 week pilots using tools already embedded in existing systems, such as Primo, rigorously measuring time saved and error rates before any wide-scale deployment is considered. Phase 2, Build Guardrails. Governance policies should be established in alignment with ACRL AI competency frameworks, ensuring that every adopted tool maintains strict human oversight, algorithmic transparency, and zero-compromise data privacy protections. Phase 3, Leverage the Commons. No institution should develop AI infrastructure in isolation. Shared AI networks and active engagement with practitioner communities such as AI-4Lib reduce duplication of effort and enable validated workflows to be disseminated across the professional community. This 3-phase model reflects what the strongest library institutions are already doing in 2026. The final slide draws these themes to a concluding principle. This closing slide articulates the foundational conviction that underlies the entire framework presented in this lecture. The strongest library institutions in 2026 are not those chasing every new AI tool as it emerges. They are institutions that are intentional, strategic, and governance-first in their approach to technology adoption. The proposition that AI does not replace professional expertise, it amplifies it, is not merely reassuring rhetoric. It reflects the empirical reality demonstrated across each domain examined today, from semantic discovery to ethical governance, from metadata automation to staff competency development. The library professional's capacity for critical judgment, ethical oversight, and authoritative validation becomes more, not less, indispensable as AI integration deepens. For ongoing practitioner workflows, community frameworks, and weekly updates, we encourage engagement with the AI-4Lib initiative. Thank you for your attention to this discussion.